Okay, so we'll start. Can you hear me? Okay, so good morning to everyone. We'll start from where we have stopped last time. So this example, I have given some instruction to do this. Then the last week I have uploaded the answer also. Uh, but let me little bit explain. So you can see the screen, right? Okay, then for this example, as we discussed, we need 12 variables to formulate this problem. These 12 variables we can define like this. Number of units sent from each origin to each destination. So this is the notation that I have used x1, x2, x3, x4 like that. Now if you want, you can take x11, x12, x13 like that. There is no issue in selecting the variables as you wish. Okay, now with this, we can formulate the problem. I mean, we can write all the information in the question in terms of these 12 variables, then we'll end up with the linear programming problem. Now, for example, if I write this statement, this is 10, 0, 20, so these are unit transportation cost. If I write this statement 10 x1, 0 x2, 20 x3, using all the values in this table with the variables defined, and the last value is 18 x12. So I'm using this notation 1, 2, 3, 4 up to 12. If I write this statement, the meaning of this statement is the total transportation cost. So if the unit transportations are given, then with the introduction of these variables, we have defined how many units we are going to transport from each origin to each destination. With this, we can write this expression. This expression represents the total transportation cost, and we want to minimize this function. So then we can take this as objective function. So I assume that now you remember what we have discussed about linear programming problem. In a linear programming problem, there are components like objective functions, then problem constraints and non-negativity constraints. The objective function always represent our objective, and the problem constraints represents our limitations. So we are working with limited resources. The conditions related to those limited resources are represented by constraints. Problem constraints. Then non-negativity constraint means we want to introduce the conditions that variables should be positive. Therefore, we'll write non-negative constraints. So these three components are there in any linear programming problem. Then with these variables, we can write this function. This is the objective function because our objective is to minimize the total transportation cost. Okay, so then with this one, we can go to the constraints. Now the variables are like this. This x1, x2, x3 represent number of units sent from A to D. Then x2 means units sent from A to E. X3 number of units sent from A to F, and x4 number of units sent from A to G. Now if I take the sum of these four variables x1, x2, x3, x4, the total represent all the number of units sent from A to destinations. Be from A to D, A to E, A to F, or A to G, whatever. X1 plus x2 plus x3 plus x4 gives the total number of units sent from A to all destinations. Then
Recording in progress.
If I take the sum of x1, x2, and x3, x4, as I mentioned here, it will give total number of items sent from the factory. But we know that according to the question, the capacity of factory A is 20. Therefore, the sum of x1, x2, x3, and x4 should be less than or equal to 20 because the total number of unit sent out cannot exceed the capacity of the factory. Therefore, we can write the first constraint x1, x2, x3, x4 should be less than or equal to 20. Then similarly, we can take the number of items we are going to send from B to all the destinations that represent the left-hand side of the second constraint x5, x6, x7, and x8. So this is the total number of unit that we wish to send from B to all the destinations. And it must be less than or equal to capacity, and the capacity is given here 25. Therefore, second constraint we can write x5, x6, x7 plus x8 less than or equal to 25. And similarly, we can write the third constraint. The total number of units we are going to send from C to all the destinations must be less than or equal to 15. So these are one set of constraints. Then if we go to the variables again, if I select this x1, then x5 and x9. This x1 is the number of units sent from A to D, x5 is the number of units sent from B to D, and x9 is the number of units from C to D. Then if I take the sum of these three variables, x1 plus x5 plus x9, that represents the total number of items received by site D. Total number of items received by site D. So it can come from factory A, factory B, or factory C. From wherever it comes, x1 plus x5 plus x9 represents the total number of items received by site D. If we go to the question, this site D has a demand of 10 items. Therefore, total number of items received by site D must be 10 in minimum. The minimum number of items received should be 10 because the demand is 10. It can be more than 10, but it doesn't matter, but it cannot be less than 10 because we have to satisfy the demand. And then that we can go to the constraints x1 plus x5 plus x9 greater than or equal to 10. So that is another constraint. Similarly, we can take x2 plus x6 plus x10. So that represents the total number of items received by site E. So that must be greater than or equal to its demand. Therefore, we can write greater than or equal to 15. Now, similarly, we can write for others also. Now, this set of constraints, you can see that these constraints are capacity constraints. Therefore, we cannot exceed the capacity. That is why we got this inequality as less than or equal. Then the next four constraints, these represent demand constraints. So we have to satisfy the demand. Therefore, the inequality here should be greater than or equal. So it can be either equal to demand or it should be greater than the demand. Now, with these four constraints and these three constraints and this objective function, now we can write the complete linear programming problem. So this is the complete linear programming problem for the question given. So we have to minimize this function subject to these limitations, these conditions. And these variables, all these variables must be positive. Therefore, at the end, we write this statement x1, x2, x3 up to x12 is positive. Okay, so this is the answer to the question that I have given. Now, this particular problem we name as a transportation problem also. So later in this module, we will discuss a specific problem called transportation problem. The scenario involved in that problem is also same. We have number of origins and we have number of destinations, and we have to find the transportation schedule that gives the minimum total transportation cost. So that is called the transportation problem. Now here also we are doing the same. We formulate the problem as a linear programming problem to minimize the total transportation cost. So that means we can formulate transportation problem as a linear programming problem also. So this is the solution to that problem. Okay, so any question you have about this formulation? Okay, so if no question, we can go to the next example. I have given that as an exercise, and I show that some of you have written the correct answers, but some are not correct. So I will show how to get the answer for that. Then those who have not written the correct answer can refer to that and see where you have done the mistake. Okay, so let me come back to that question. So this was the question that I have given you as an exercise and asked to submit. It says a construction project requires different number of full-time employees on different days of the week. In each full-time employee must work 5 consecutive days and then receive 2 days off. The number of employees required on each day of the week is given below. So we have this information. Monday, there should be minimum 21 employees, Tuesday 14, Wednesday 13, and like that we have that information for all 7 days. So what we are required to do is we have to formulate a linear programming problem to minimize the number of full-time employee required. So the maximum number of employees required, we can easily find. We can get the sum of all these numbers, 21 plus 14 plus 12, 15, 17, 16, 19. Then if we get this sum, that represents the maximum number of employees required. The maximum number of employees required. But here we want to find the minimum number of employees required because that gives the cost benefit for the organization. The organization want to pay salaries and wages. Therefore, the organization want to minimize the number of employees required. Now we will see how we can do that. The first thing is that we have to select the number of variables correctly. So what are the variables that we need? And here I will define the variables like that. there are 7 variables. I will define the variables in the way that x1 is the number of employees who start working on Monday. Number of employees who start working on Monday. So when someone start working on Monday, now according to the question says that they have to work for 5 consecutive days and get 2 days off. 5 consecutive days and get 2 days off. Then what will happen if someone starts working on Monday? He has to work for 5 consecutive days. Okay. That means for someone start working on Monday, he has to work Monday, Wednesday, sorry, Monday, Tuesday, Wednesday, Thursday, and Friday. Then he will get 2 days off. Then the next set of employees, they start working on Tuesday. If they start working on Tuesday, yeah, I will share the screen. So if some employees start working on Tuesday, then what will happen? They have to work 5 days: Tuesday, Thursday, uh, Tuesday, Wednesday, Thursday, Friday, and Saturday, and then get 2 days off. So that is the scenario. Okay, because now here we know that the condition, each full-time employee must work 5 consecutive days and then receive 2 days off. Okay, so once we get the variables like that, it is very easy to formulate. If I show that the table, now the x1, for example, x1 is the number of employees who start working on Monday. Then what will happen? They will start working here on Monday. Then they have to work 5 days. X1, 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 X1. So these X1 number of employees work for first 5 days of the week and then receive Saturday and Sunday off. Then similarly, if we go to the second set, uh, that is X2. So X2 is the number of employees who start working on Tuesday. Number of employees who start working on Tuesday. Then what will happen? They start Tuesday and they have to work until Saturday. And then get Sunday and next Monday as off days. Then X3, our X3 variable is number of employees who start working on Wednesday. So Monday, Tuesday, Wednesday, like we can define the variables. So X3 is the number of employees who start working on Wednesday. Then what will happen? Then when we start working on Wednesday, they have to work 5 days in a row and then get next Monday and Tuesday off. Then X4 is the number of employees who start working on Thursday. Then they have to work Thursday, Friday, Saturday, Sunday, and also next Monday. Okay. X4 number of workers with these four and this one. Then Tuesday and Wednesday they are getting 2 days off. So likewise, we can now complete this chart. We can now complete this chart. Then what will happen if we take this sum? Can someone tell me what is the meaning of sum of these numbers, x1 plus x4 plus x5, x6 plus x7? What is the meaning of this sum? If you have understood correctly the variables and this table, you must be able to tell this. So what is the meaning if I take this sum, x1 plus x4 plus x5 plus x6 plus x7?
Number of employees working in one day.
Yes. So if I take this sum here, see x1 plus x4 plus x5 plus x6 plus x7. So this represents the number of employees work on Monday. Number of employees work on Monday. So this is the meaning of this sum, x1 plus x4 plus x5 plus x6 plus x7. But according to the question, it says that the number of employees required for Monday is 21. Number of employees required on each day of the week is given in this table. Therefore, the minimum number of employees should work on Monday should be 21. Therefore, we can write the first constraint as x1 plus x4 plus x5, x6 plus x7 must be greater than or equal to 21. So it can be equal to 21, that is the best case. But it can be more than 21 also, but it cannot be less than 21 because we need 21 employees. So this is the first constraint is for the Monday requirement. Now for the Tuesday also we can do the same. If we take this sum x1 plus x2 plus x5 plus x6 plus x7, this represents the total number of employees work on Tuesday. Work on Tuesday. But when we define the variable, we define the variable as x1 is the number of employees who start working on Monday, But when we come to the sum of these variables, it gives the total number of employees working on Tuesday. So the requirement for Tuesday is 14. Therefore, the sum of these numbers must be greater than or equal to 14. So we can write the second constraint. This must be greater than or equal to 14. Now similarly, we can write the constraints for all 7 days. So we can write the constraints for all 7 days. Then if we go to these variables, if I take the sum of these numbers, x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7, if I get the sum of these numbers, This represents the total number of employees required for whole week. Total number of employees required for the whole week. And our objective of the problem is to minimize the number of employees required. Minimize the number of employees required. And here this sum gives the total number of employees required. Therefore, we should minimize the sum of these variables. So that is what we can write as the objective function. We have to minimize x1 plus x2 plus x3 up to x7. We want to minimize this function. Okay, so minimize subjected to these variables. And these variables represent the number of employees. Therefore, number of employees cannot be negative. Then we introduce this constraint x1 up to x7. All the variables are positive. So this completes the formulation of our linear programming problem for the given case. Okay. Any question about this formulation? Okay, so if you have any question about the two problems that I have explained today, you can ask now. Okay, so if no question, we can go to the next part. So we have discussed a couple of examples. This is the first example. Then second example, this one. Then we have discussed how to incorporate the minimum number of items there, the greater than or equal constraints. Then discuss how to formulate this transportation problem as linear programming problem, and the last example. So now I want to show you that how we can get a solution to this type of problem, and what is the meaning of that solution. So the interpretation of solution. So that is the next part. Now the formulation of the problem, you can practice. You can find enough examples from the web and you can practice. Now today then we'll move to the solution part, how to get the solution. Now I ask you to be ready with Excel. Do you have access to Excel now, at least majority? Do you have access to computers and Microsoft Excel? Okay, so let me share it and come to the Excel and show how we can use Excel to solve linear programming problems. Okay, just we'll wait some time until I come back with the Excel. Okay, now here I am working on Excel now, and I want to solve this problem by using Excel. Now here you can see that this is a maximization problem. So when we have to maximize some function, we call that problem as a maximization problem. If we have to minimize something, we call it as a minimization problem. Now, for example, this problem, this is a maximization problem. And this transportation problem case, this is a minimization problem because our objective function is to minimize something. So this last one also is a minimization problem because we have to minimize the objective function. Okay, now for this particular example that I am going to solve using the Excel, this is the maximization problem. We have to maximize this function subject to this constraint. Okay, now here we have x1, x2, and x3. If you want, you can use this x1 and x1, x2, and x3, but for the convenience of explaining, I am taking these variables as x, y, and z. So then that will be easier to understand, but the same concept without any problem, you can use x1, x2, and x3 also. But let me use the three variables as x, y, and z. Then some of you will find it easy to understand this solution procedure. You know, same question, there is no change. I have changed x1, x2, x3 to x, y, and z. Okay, so with this, we'll solve this problem. Okay. Now here, what I am going to do is that I am going to using the solver function in the Excel. Okay. In Excel, there is a function called solver. Okay, so using this solver function, we can solve this. Now, sometimes this solver function has not been installed in the Excel program. If it is not installed, we have to first install. So it is not difficult to install. That's an add-in component we can easily incorporate into the Excel. Then how to know that whether it is installed or not? We can go to this data tab in the Excel. When we go to the data tab, somewhere here you can see this word solver if it is there. Now in this my program, this solver function is not added, therefore it doesn't show here. And if it is not added, the first thing that we have to do is that we have to add it. So I will first explain how you can add this solver function. If you want, you can write down the steps or you can remember, no problem. Okay, so you have to go to this file and options. Then here you can see that there are Excel options. Then from this set of options, you can go to this add-ins. You can go to add-ins. And here you can see that manage Excel add-ins. Then you have to click go here. Then it will display the available add-ins. So you can see that the last one is solver add-in. So that is not ticked here. So we have to tick this and click OK. So I will show the steps again. So we have to go to file, then options. Then from this menu, we can select add-ins. Then at the bottom, we have manage Excel add-ins. Then click go. Then click the solver add-in and click OK. Okay, now that is done. Now we will see, we'll go to this data tab. Now you can see that the solver part is added here. Solver part is added here. Now using this solver function, we can solve this problem and get the answer. Okay, so I will step by step show how to do that. You have to carefully look at. If you have any question, you can ask, because here we have to use some formula, and then we have to use this solver function. So when we come to the solver function, we will have a dialog box like that. In this dialog box, you have to enter some specific details. Now here you can see that first part here we have set objective. So that means we have to set our objective function in this box. But objective function in the sense that we have to write it as a formula. Okay, so I will show you how to do that. Then we have to select whether we want to maximize our objective function or minimize our objective function, or whether we want it to be a specific value. So that also facilitated by Excel. Okay, so maximum or minimum. Then we have to enter our variables here. If we have X and Y, we have to enter that X and Y. If we have more than that number of variable, then we have to include it here also. Then the subject to the constraints. Now we have these constraints, so we have to enter these constraints here, but in the form of formulas. In the form of formulas. Okay, then after that we can get the solution. To enter those formulas here, before entering the formulas here, we have to do some work. That means we have to enter these objective functions and formulas, sorry, constraints in the form of formulas in our Excel sheet. So we'll do that one first. Okay, so So look at the steps carefully. If you want, you can write down. Okay, now here we have three variables. These three variables are, say, x, y, and z. Okay, now I want to get values for x, y, and z. So at the end of the solution procedure, my objective is to get the values for x, y, and z that gives the maximum objective function value, because our problem is a maximization problem. So once I get the values for x, y, and z, any other value that we substitute for x, y, and z will give a lesser value than the maximum value. So that is the objective. But we have to find the values for this x, y, and z subject to these conditions. Okay. So we cannot have x 1000, y 2000, and z 3000, because if we write like that, this first constraint, the left hand side is very much higher than the right hand side. So that is not allowed, because we have this less than and equal sign. Therefore, whatever the value we get for x, y, and z, when we substitute into these constraints, the left hand side should be less than 600. And also when we substitute these values in the second constraint, the left hand value should be less than or equal to 720. So with these limitations, we are finding values for x, y, and z. With that condition, the values we get for x, y, and z, when we substitute in this objective function, we get the maximum possible value that we can get. Okay, now here x, y, and z. So I want to program the problem in a way that after solving the problem, I will get the x value to this cell. Okay. Now for the easy referencing, I am going to highlight. So the x value I will get here, and the y value, and also z value. So no need to do like that, but just for the convenience of explaining, I have highlighted these cells, because after solving, I will get the answer to x into this cell, y into this cell, and z into this cell. Okay, then our objective function value, uh, I want to get my objective function value into this cell. Okay, now if I want to have the objective function value here, the objective function should be 6x plus 4y plus 8z. Okay, then I can write the formula, right? It should be 6 times x. So x means now I get my x value to this cell. Therefore, I will give this cell reference here, H2. H2 is the cell for which we get the value of our x variable. Therefore, 6x means I have to write 6 into this cell. Then plus we have 4y. Therefore, 4 into y means the cell for which we are going to take the value of our variable y. So I will do that. Okay. Similarly, we can do it for the other one also. then 8 into Z. Okay, now we'll see that we get 0 here because still we don't have any values here. Okay, then as a sum we'll get 0. Okay, just you can write down anything if you want. I will give you about 2-3 minutes. You can practice on your sheet also. So at the same time, if you have any question, you can ask. Okay, so it looks that no questions. So now we have formulated our objective function here as a formula. Okay, so you can see that this is equal to 6x2 plus 4h3. H3 is the cell reference, then 8h4. So h2, h3, and h4 are the cells that we are going to take the answers for x, y, and z. Then let us write our constraints. Uh, so when you solve, no need for you to write like this, but for the purpose of explaining, I am writing these words here. Constraints. Now we have two constraints here. 1, 2. Okay. Now constraints, we have two sides, left hand side and right hand side. Okay. So left hand side, we will write in the first constraint. Left hand side, we have 8x plus 6y plus 10z. Okay. Now that also we have to write as a formula. Okay, so we write 8x. Okay, so 8x means this cell 2 plus 6y sorry, not y. So we have to go to this cell plus 10z. Okay, so this is the left hand side of the first one. Okay, so let me write as this is the left hand side of the first constraint. Now you can see that now still it is 0 because we don't have values for x, y, and z. Then if I write the right hand side of the first constraint is 600. Right hand side of the first constraint is 600. And the second constraint 4x plus 4y plus 86. So we can write it as a formula. 4x plus again 4y plus 8z. So z means h4. So that is the left hand side. And the right hand side should be 720. Okay, so this is the second constraint. Now here we are not going to enter this non-negativity constraint here. I will explain that later why we are not going to enter here. So if you want, you can enter here also, but without entering that, we can do it. Okay, so you can do it in your Excel now. You have to formulate this left hand side of the first constraint and the right hand side of the first constraint. Okay, so do it now. Because after entering these two constraints, then we can go to the solver function and solve the problem. Okay, see whether you can formulate as I did here. Then we'll go to the solve option and solve that. Okay, now with this, we will use this solver function now. Okay, now we will go to this solver function, data and solver. Okay, now just take 2-3 minutes and see whether you can play with this function and see whether you can just find some way to enter what we have formulate here into this one. Then I will show you how to do that. So I know that you are not familiar, but you can something think of here and try to enter here. Okay, so it's not if not definitely I will show you how to enter these objective functions and constraint here. Now I will allow you about 2-3 minutes to play with this and check how this solver function work. So at the same time, you can ask if you have any question. Okay, now here we have to set the objective function here. Just see how I am doing that. In the objective function, now we have formulated here. So I have to just click on this cell. Okay. So that is the way of doing that. Then after that, there is something called by changing variable cells. By changing variables cells means we have to enter the variables here, variables in our problem. Okay, so the variables in our problems are x, y, and z. So we have to click and drag like this. Okay, click and drag, then it will take the range. It will take the range. Then subject to constraints. Now see whether you can enter the constraints like that. Then I will explain how to enter the constraint. Okay, now I will enter the constraints. We have to go to here, subject to the constraints. Then click add here. Then you can see that the cell references are there. So this part represents the left hand side and this part represents the right hand side. Okay, just wait 1 minute. Okay, now from this side, we have to enter the left hand side of the first one. So I have to select this cell, left hand side. Then the right hand side also click this constraint part. Then you have to select the right hand side of the first constraint. Right hand side of the first constraint. Then from here, you can see that there are a number of options: less than or equal, equal. Then we can see greater than or equal, integer, binary, some different values we can enter. So now we are not going to do that because our constraint is less than or equal. So we will just select that one and then click add. And we have to add the second constraint also in a similar way. We just go there and then go to the constraint, select the right hand side, click OK. Then you can see that the first two constraints are here. First two constraints are here. Okay, so with that, uh, the objective function and the first two constraints have been entered here. Now what we have to do is we have to enter this non-negativity constraints here. We have to enter the non-negativity constraints here. Okay, so what we can do is again click add here. Then we have to enter the constraints that x, y, and z greater than or equal to 0. So we have to do it one by one. So we'll first go to the first variable x. So here you have to select the left hand side as this x cell and then select greater than or equal and put 0 here. Then again add. So you have to select the next variable y and again do it and you have to enter 0. Then the third one add the variable z again 0 and then click OK. Okay, now you can see that objective function is here. All 5 constraints are there. 5 constraints in the sense that we have 2 problem constraints and 3 non-negativity constraints. 2 problem constraints and 3 uh, non-negativity constraints. Okay. If you have any question up to this point, you can ask now. So any question you have up to this level? Okay, I will explain again this dialog box here. See whether you have it or not. Objective function we have entered here. So as a formula, then we have set the criteria, whether it is maximization or minimization. So since we have maximization problem, we put that one here. Then the variables. So by changing variables, cells means the variable that we are using. So I have selected that. To select this variable part, what we have to do is we have to drag, select and drag. Then only it will take according to their format. Then from this box, we have entered these two constraints and the non-negativity constraint. Okay, so that's it. So you don't have to change these things here. So these are according to the algorithm that this Excel program is using. Therefore, just keep it as it is. And now we are about to uh, solve the problem. So when I click this solve button, we will get the answer here. So the x value into this cell, y value into this cell, and z value here, and the objective function. Okay, so you have to carefully recognize that. So now I am going to click this part solve. Okay, so when I click, it will ask keep solve a solution. So it's okay. Then you can see that we get some values here. Okay. Now, don't worry about these values. These are a number of decimal points, so you don't have to worry about this one. And this is the x value, this is the y value, and this is the z value that this program is giving us. Okay, so with these values, the objective function value is 480. So this is the meaning of here. Okay, so when we have to solve this type of problem using the Excel, what we have to do is we have to first enter our variable cells, then the objective functions and left hand side of the constraints we have to enter as formula in terms of the cell reference of these variables. Then after that you can go to the solver function and you have to enter the objective function variables and these constraints. Then when you click OK, then you will get the solution to the desired cells here. Okay, so you can now do it and see whether you get it. If not, you can ask me now. Okay, now if you have any question, you can ask. I will explain again what I have done here. So I have first selected the variables. Then I have formulated the objective function and constraint as formulas. Then after formulating that, we use this solver function and enter the objective function, the optimization criteria and constraints here. Then by clicking this solver function, we will get a value. Okay, so it looks that you don't have any question. Before I explain this solution further, I want you to do one question by yourself and give me the answer. Okay, so let me take one problem. Okay, do this question by yourself and send me the answer. So you can have a screenshot of your answer and send me to the chat. So if you have properly followed what I have done, you can do this easily. For x1, x2 and x3, you can just take x, y and z, so no problem. So what you have to do is you have to identify the cell references, then enter the objective function and constraint as formulas, then use the solver function and do that. Okay, so we take about 10 minutes to do that, and you can take a screenshot of your answer and send it to me, then I will comment on that. Okay, start doing this. Please do this and send a screenshot of your answer to me. Okay, so I am in the class, and therefore, if you have any question, you can ask regarding the previous question or formulation about this question. If you have any question, you can ask. If not, you have to do this question using Excel and send me a screenshot of your answer. Now here also instead of x1 and x1, x2 and x3, you can use x, y, and z for the convenience. so this is the question. So still I did not get any answer. Please try to do it quickly and send me the answer. So this is not difficult if you understood the procedure that I followed in the last example. If you have any question, you can ask.
Excuse me, sir.
Yes.
Sir, object cell එකට මොකද type කරන්නේ sir?
XYZ වලට cells දාගත්තට පස්සේ ඒක ෆෝමියුලා එකක් විදිහට type කරන්න එතන 4x + 2y + z. XYZ කියන එකට XYZ නෙමෙයි type කරන්නේ එතන type කරන්න cell reference එක.
හරි. Thank you.
Okay, so let me show you the steps. Okay, so here we have x, y, and z variables. So I will keep a cell space for x, y, and z, and also the objective function value. Objective value, there is a cell for that. So I have received a couple of answers. 2 answers. Let me check that one. So I'll check that later. Okay, so then the objective function value I have to write 4x plus 2y plus z. Okay, so write 4 into x plus 2 into sorry, here I have done a mistake. 4 into x. X means I have to select this cell I5 plus 2 into y plus then z. So that is the objective function value. Now in this example, I am not going to highlight these cells in colors because now you understand. Just for you to understand, in the last example, I have done this. Okay. Then the constraints, we have left hand side and right hand side. Okay, so the left hand side, I will write first one x plus 3y minus z. Okay, so the x means this cell plus 3y, okay, into y, then minus z. Then the right hand side, that is 15. Then next one, x minus 3y. Okay, somebody's mic is working. Please unmute. If you do not have any question to ask, please unmute yourself. Okay. The second one, x minus 3y. So x minus 3 times y. That is the second constraint. The left hand side, right hand side, that is 5. Okay, so Gihan, you have to unmute your mic. So 20 B2 19, Gihan, please unmute your mic. Then the third constraint, 3x plus 2y plus z, and the right hand side is 4. Okay, then everything is there, so I will go to the solver. The set objective. So set objective means I have to set the objective function formula here. Okay, so it's done. Then the criteria, our problem is now minimization problem. Therefore, I have to select the minimization one here. Then by changing variable cells, we have to select the variables. Just click and drag. Then it will select all the variables. Then the constraints, add first one left hand side, and then the right hand side. So right hand side of the first one, Then first one is less than or equal 1, so it is selected by default. Then add the second one left hand side, again that is less than or equal 1, right hand side, just select that one. The third one, the left hand side is here, this time it is greater than or equal 1. You have to select the right hand side, and we will add the others also, x, y, and z greater than or equal to 0. So x variable must be greater than or equal to 0. Then add y variable greater than or equal. We have to type 0 here. Then add z greater than or equal 0 and click OK. Now all are there. Objective values, variables, and all 5 constraints. There should be 6 constraints. Yeah, 6 constraints are there. Then just take this solver button and click OK. Then you will see that there are values for x, y, and z. All are positive values. Then objective values are also there. Okay, so this is the solution to this problem. Okay, so any question? So now today I have explained 2 questions how to do using the Excel solver function. So you have to practice that. Now it is very easier to use the Excel for solving linear programming problems. Just you have to enter the objective function and constraint in terms of formulas, then you can use the solver function. So I want to little bit explain about the solutions and constraints of these 2 examples. So I will do that in the next class. But if you have any problem regarding this formulation in solver, you can ask now. If no question, we can stop the class for today. Still, I will give you about 1-2 minutes to ask question. So you have to practice. You can find some linear programming problems, so you can even write by your own and see whether you can solve using the solver. So there are other methods like graphical methods and analytical methods. So we will discuss those in the next classes. So I will show you some other softwares also. How to use MATLAB to solve, how to use some other software to use. I will show you in the next classes. Okay, so if you do not have any other questions, we will stop the class for today. We will be having the next class again next Saturday. So probably at the same time, 7:30. So I will let you know. Okay, it looks that you don't have questions, so we'll stop the class for today. So we'll be meeting again on next Saturday. Thank you for your participation.
Recording stopped.